Ever wonder why some AI answers take forever to explain something simple? Like, why does a chatbot need 10 paragraphs to solve a math problem that could be done in a sentence? Well, that's the problem researchers are tackling with budget guidance, a smarter way to control how long AI thinks without making it wrong. See, large language models, LLMs, like the ones powering chatbots or virtual assistants, are amazing at reasoning. But here's the catch: they often overthink. Imagine a student who writes a 20-page essay to answer a single question. Sure, it's thorough, but it's also slow and wasteful. For AI, this overthinking uses way more computing power than it's worth. So how do you tell an AI, hey, keep it concise? Traditional methods either force the model to stop abruptly, like cutting off a story mid-sentence, or fine-tune the model itself, which is time-consuming and risky. But what if there was a way to gently guide the AI, like a GPS that tells you, you've got 5 more blocks, but don't rush? That's where budget guidance comes in. It's a clever trick that uses a lightweight predictor to estimate how much longer the AI needs to think. Think of it as a little helper that says, you're halfway done, let's wrap this up before we go over budget. This predictor doesn't change the AI's core knowledge, so it stays accurate, but it keeps the thinking process efficient. Here's the magic. Instead of brute forcing the answer, the AI uses this predictor to softly adjust its reasoning. It's like having a teacher who says, you're on the right track, but let's not get lost in the details. And the results. On tough math problems, this method cuts thinking time by 37%, while still getting 26% more answers right than older methods. Imagine you're baking a cake. A traditional approach might have you mix ingredients for hours, overcomplicating the recipe. Budget guidance is like using a timer and a checklist, ensuring you're done just in time without sacrificing the taste. This isn't just about speed, it's about making AI more practical for real-world use. Whether it's a chatbot responding instantly or a robot solving problems on the fly, budget guidance shows how we can teach AI to think smarter, not just harder. Next time you see an AI answer a question, you'll know there's a whole team of invisible helpers working to keep it fast, focused, and just right. Thanks for watching. If you want to see how this plays out in real examples, hit subscribe and check out our next video. Until then, keep wondering, because the future of AI is reasoning its way into our lives. Hey there! Ever wondered how math can solve puzzles hidden in vectors and binary numbers? Today, we're diving into 2 mind-bending problems that show how math isn't just about numbers. It's about logic, patterns, and creative problem-solving. Let's break it down. First up, vectors and cross products. Imagine you have 2 arrows in space, and v, the cross product, times v gives a new vector perpendicular to both, like a magical third direction that pops out of the page. But here's the twist. We're told this cross product equals and is. How do we find v? Let's start with the basics. The cross product formula involves determinants, which might sound intimidating, but think of it as a recipe. For a times v, we set up a matrix with I, j, k unit vectors, then multiply and subtract components. The result? A new vector with 3 parts. I component, v3, v2. J component, v1, v3. K component, v2, v1. So a times v becomes. And we know this equals. That gives us 3 equations. 1v3, v2 equals 1. 2v1, v3 equals -2. 3v2, v1 equals 1. But wait, there's also the dot product condition, of v equals 2. Since that's just v1 plus v2 plus v3 equals 2. Now we've got 4 equations. Solving this system means substituting variables step by step. For example, from equation 3, we find v2 equals v1 plus 1. Plugging that into equation 1 gives v3 equals v1 plus 2. Substituting both into the dot product equation, poof. We solve for v1, then backtrack to find v2 and v. The answer? But why does this matter? Cross products are everywhere, from calculating torque in physics to rendering 3D graphics. It's math's way of telling us, hey, there's a hidden direction here. Now let's switch gears to binary-to-octal conversion. Take the binary number 10,101,001,110. Convert it to octal. Easy if you know the trick. Octal is base 8, and here's the key. Each octal digit represents 3 binary bits. So we split the binary number into groups of 3, starting from the right. If the leftmost group has fewer than 3 bits, we pad it with zeros. For 10,101,001,110, split into. Wait, no, that's not right. Let's count correctly. 10,101,001,110. Right arrow 10, 101, 1, 110. Now convert each group. 102 equals 28. 1012 equals 58. 12 equals 18. 1102 equals 68. So the octal equivalent is 25,168. This method works because 8 is 23, making the conversion straightforward. It's a handy shortcut for programmers and engineers dealing with binary data. Math isn't just about crunching numbers, it's about unlocking hidden structures in the world around us. Whether it's vectors guiding 3D graphics or binary code shaping digital systems, these problems show how math powers the technology we rely on daily. Thanks for watching. If you want to dive deeper into these concepts, hit subscribe and check out our next video. Until then, keep exploring, because the language of the universe is written in math.